parameterize the line r of t equals 1 plus 2t, 3 plus 4t, 5 plus 6t using the arc length parameter. So this is a line in the parametric form. Well, I guess we would say the parametric form is x equals 1 plus 2t, y equals 3 plus 4t, and z equals 5 plus 6t. So we'd like to re-parameterize this. So right now the parameter is t using the arc length parameter. The special thing about the arc length parameter is that when there's a change in the arc length parameter, which is denoted by s, then that's exactly how far you've moved on the curve as well. So the arc length parameter, when it changes by 1 unit, that means that you've moved 1 unit along the curve. With this parameter t, if t changes by 1 unit, who knows how far you've actually moved. I mean, let's check. If t goes from 0 to 1, if t is 0, then the point that you're at is the point 1, 3, 5. And if t is 1, then the point that you're at is 3, 7, 11. So a change in t of 1 gives us a change in the position of r of the square root of 3 minus 1 squared is 4, 7 minus plus 16 plus 36, much more than 1. That's the square root of 56. That's more than 7. So a change in this parameter of 1 yields a change in how far we've gone on the curve of 7. So that's definitely not an arc length parameter. An arc length parameter, when the parameter changes by a certain amount, then you've moved that far on the curve. And the formula for the arc length parameter, s, is to integrate the speed of the curve. When you integrate speed, you get the distance traveled. So that's why there's this correspondence between the value of s and how far you've traveled on the curve. So there's our arc length parameter formula. S is some function of t. It's this function. It's a function defined by a definite integral. It's the integral from 0 to t of the magnitude of r prime of u du, where u is just a dummy variable here. So in our case, r prime of t is, take the derivative, it is the vector 2, 4, 6. 2, 4, 6, that's r prime of t. So the magnitude of r prime of t is the magnitude of this vector. So this is a constant. R prime of t is a constant, so the magnitude is a constant. So we're just going to be integrating a constant here in this problem. So r prime of t, the magnitude is the square root of 2 squared plus 4 squared plus 6 squared. Do some arithmetic on that, and you get the square root of 56. I think it's that number right there. What do you know? So, and well, let's see. We can pull a 4 out of that, right? That's 4 times 14, so it's 2 times the square root of 14. Not much better, but okay. No, it's 14 is square free. So now s is simply the integral from 0 to t of 2 square root of 14 du. So this is just 2 square root of 14 times t. This is the final answer. Skipping the step where we integrate and you get 2 square root of 14 u, and then plug in 0 and t. When you plug in t, you get this, and when you plug in 0, you get 0. So s is just 2 root 14 t. That's it. So s is just a multiple of t in this case, which means that if we want to re-parameterize this using s, then we actually need to solve this equation for t. So s equals 2 root 14 t. We would like to solve for t and substitute into r. Substitute into r. And then we will have accomplished the task. So obviously t is just s divided by 2 root 14, or what? S root 14 over 28, if you want the radical in the numerator. So let's do it that way. So let's plug this in for t. So r of s is equal to 1 plus 2 times this. So if I do 2 times this, I get s root 14 divided by 14. And then 4 times this, so 3 plus 4 times t. So 3 plus 4 times this is going to be s root 14 over 7. And then 6 times t. So 5 plus, comma, there should be a comma there. Comma, 5 plus, we need 6t, so if I multiply this by 6, we'll cancel a 2 and there will be a 3, so there's going to be a 3s root 14 divided by 14, so we can write the line in this way. And now, if s changes by a certain amount, then r of s will also change by that amount. So that's the arc length parameter. A change in the arc length parameter corresponds to a change of exactly the same amount in the curve, the position of the curve. Okay, so that concludes the problem. The general formula, again, the arc length parameter, you have to integrate the speed of the curve. Speed from 0 to t, that'll give you a parameter s. This function, this is a function, f of t. This function has an inverse. So t was f inverse of s. So this was s equals f of t here. S was equal to this number times t. That was our function of t. We had to solve for t. That gives us the inverse of f. So the inverse of 2 root 14 times t is s over 2 root 14. So t gets replaced by f inverse of s. And then you have r in terms of s. So you've parameterized in terms of the arc length parameter. So in this case, since we had a line, the speed of the curve was constant, and we integrated this constant. So that was pretty simple. And then inverted that easily enough. The inverse is just divide by the coefficient here, 2 root 14, and then plug that in for t.